Alright folks, Mr. Long here again. Let's talk more about Vertex, and we're going to look at transforming the standard form right here into the vertex form, x minus p squared plus q. I think you now understand why parabolas have vertex, this idea that turning negatives into positives creates relationships where you get minimums and maximums, depending on whether the coefficient, the number in front of, that is, the square, is positive or negative. And we're gonna find vertex two different ways. The easy way, which is negative b over 2a, we developed that earlier with some partial factoring, and now we can just go to the shortcut. So when you're solving problems, I would encourage you to use negative b over 2a, and you should really only be completing the square if it's requested in a question, or you're working with just variables. Completing the square is a process that you have to learn according to the curriculum, but it's certainly not the most efficient way of finding out a vertex. So let's take a look at doing this. So again, the goal here is that you can get an equation given in what's called a standard form, which would normally be ax squared plus bx plus c, but we're only going to do x squared plus bx plus c, or negative x squared plus bx plus c. And I know this is a review from last year, however you may or may not remember. And again, if you have a way to do it from last year that you're very confident with, please use that. I'll show you a little bit of a different way, and then you'll have some choices to make. And even if you want to learn it the way you did it last year, I'd be happy to show you that as well. Again, I want to connect this to the idea of a perfect square, because we are, after all, completing a square. But anyway, let's do it the easy way first. In this case, we've got y equals x squared plus 6x plus 10, negative b over 2a. In this case, a equals 1, b equals 6, negative b over 2a, which happens to be the x value of the vertex. The x value of the vertex is negative of 6 over 2a, and a is 1, so that's over 2, which equals negative 3. Now the y value of the vertex is, ooh, that looks like a b. It's negative 6. And again, remember to pause it at any point in time if you need to. The y value of the vertex, what I need to do, folks, is substitute into that equation the x value of the vertex. So I'm going to replace everywhere where I see an x now, I'm going to replace it with a negative 3. So it's going to be negative 3 squared plus 6 times by negative 3 plus that 10. Okay, and then what does that work out to? The y value of the vertex, whoops, will work out to negative 3 squared, which is positive 9. 6 times negative 3 is negative 18. That makes negative 9. Negative 9 plus 10 is 1. So I've got an x value of the vertex of negative 3. I've got a y value of the vertex that is 1. Using what we are using right now, that gives us that the y value for the equation is a x minus p quantity squared plus q. Well, let's see, that means that our p value in this case is negative 3, and our q value is 1, the y value. So it's, our a value is 1, x minus negative 3 plus 1, which will give us y equals 1 bracket x plus 3 squared plus 1. And that means our vertex is, of course, at negative 3 comma 1, and it will be opening up. So we could sketch that as well, of course. So now let's go over and let's complete the square. It is not as straightforward as that. Negative b over 2a to get the x value of the vertex is incredibly easy. Let's take a look at it. So we're going to complete a square. So it would make life easier if I were to complete a square and all I had to worry about was that. So what I can do temporarily is to subtract 10 off both sides. So I'm going to end up with y subtract 10 equals x squared plus 6x. Now we have been working with squares. We were checking to see whether or not quadratic patterns were perfect squares or not. So one of the ways we did it was this. We took our x square there, so that represents that x square, and then we take half of our 6x and we write 3x here and 3x here. So we really end up with x plus 3 by x plus 3, and now we literally have to complete a square. So how do we do that? 3 times by 3 is plus 9. Now, I can't, folks, what's really important here is to complete a square. To make a complete square, I've got to add 9. Now, can I just add 9 arbitrarily to that side of the equation? No, I can't. I have to add 9 to both sides, or add 9 and subtract 9, which is adding 0. So what I'm going to do is, I'm going to just take that and I'm going to say, I'm going to do plus 9 to both sides. So I'd end up with y minus 10 plus 9 equals x squared plus 6x plus 9. Now I have a perfect square. Okay, I have a perfect square. And I can represent that like so. X plus 3 squared. But remember, I had to literally complete a square. I required adding 9 onto each side to get it in a perfect square form. Oh, by the way, I need to simplify this. Y minus 10 plus 9 is y minus 1. Now, I don't write my equations as y minus 1 equals. I now have to add 1 to both sides to get rid of the 1 on the left. So I have y equals x plus 3 squared plus 1. That's actually not that hard. Maybe that's, in these cases, it's just as easy to do negative b over 2a. So again, that gives me a vertex of negative 3, comma 1. And that would be smiling, opening up. All right, folks, so the whole idea here is, just to summarize, is to isolate your first two terms. And after that, which requires you to subtract 10 in this case on both sides. And then I actually have to take what I've got, the x squared and the 6x, and I can draw a square if I want over here. And I actually have to literally complete the square. That's what the process is. So 3 times 3 is plus 9. If I'm going to plus 9 to create a full square, I can't just arbitrarily add 9 to one side without doing it to both. So it said add 9, so I added 9 on the left side and 9 on the right side, and now I've got my perfect square form. Let's try a couple. We're going to look at the negative now. And I think for this case, I'm just going to do the x value of the vertex for negative b over 2a, just because I don't want to run out of, spend too much time on something that's quite easy. So negative b over 2a, negative x squared plus 6x plus 10, so that's going to be the negative of 6, that's our b value, all over double of a. Well, a is negative 1, so that's negative 2, so the x value of the vertex is then 3. So that tells me I'm going to end up with x minus 3 squared as part of my vertex form. So again, you'll notice that this example is almost exactly the same as the last one. The only real difference is that there's a negative coefficient in front of x squared, and so that requires a bit of understanding and knowing what to do. You can't complete a square, by the way, for a negative x square. Imagine that you had a negative x square there. There is no way to make a square there, because with a negative, one side would have to be positive, the other side was negative, and you would no longer have a square. So we're going to have to eliminate that negative somehow. But just to begin, I'm going to subtract 10 off both sides again. Y minus 10 equals negative x squared plus 6x. Now I noticed here, what I've just said is I can't complete a negative square, but I can complete a positive square. So I want to get rid of this negative. Well, I could divide everything by -1, or I can multiply by -1. This to get the same result, right? So what I'm going to do is just multiply everything by -1. So times by -1, and every single term will change. So this become -y plus 10 will equal positive x squared minus 6x. Okay, so that's what that looks like. And now I can complete the square. So I go over to here, and I've got x squared, -3x, -3x, and so that's x minus 3 by x minus 3, and -3 times -3. It's time to complete our square. I have to add 9. So it requires 9 to complete the square. Well, that means I have to add 9 to both sides. -y plus 10 plus 9 equals x squared minus 6x plus 9. And now I recognize that as a perfect square form, x squared minus 6x plus 9. And on the left side I've got some simplifying to do as well. So that would just be -y plus 19 will equal x minus 3 squared. So what I need to do in this case now is I don't want to have an equation that includes both y and 19 on the left side, so I've got to minus that 19, and so I'll subtract 19 off both sides, and I'll end up with -y equals x minus 3 squared minus 19. But again, I don't really want to have an equation that is -y. I need it to be positive y for my equations. So once again, I could either divide by -1, but if I do that I have to do it every term, or I have to multiply by -1. I find it more intuitive to multiply by -1, but you know, it doesn't matter. Whatever you would like to do is fine. So -y times by -1 is positive y, and then I'll have to introduce a negative in front of the x minus 3 squared, and the -19 will become positive 19. And there I have my vertex form with a vertex at 3, 19. And so in other words, 3 here, 19 there, and it would be frowning as it's opening down. Alright, so y equals negative bracket x minus 3 squared plus 19. Completing the square with a negative. And we have one more left to do. And again, you're going to want to slow this down, maybe go back and look at it again, pause it, and ask, maybe talk to someone else about it as well. So one more. What we're going to do is, I was going to do a very, very challenging one like this, but I think what I'll do instead is I might change this up a little bit if you guys don't mind. So one of the things about grade 11 is there's really an expectation that you can, and I'm not even going to do this with -b over 2a, I'll just complete the square. There's an expectation that you can complete the square with fractions, and so what we're going to do is y equals, let's do x squared minus, I'll do -x squared minus 5x plus 1. And that's what we will do. So, and again, you have to use fractions. I don't want to see decimals. Even though decimals in this particular example work nicely, sometimes it won't. If you have thirds, for example, and we end up with thirds or something like that. But you should be able to work with fractions. So, let's try it with a negative out front again. So first things first, let's clear out that positive 1 from both sides. So I want to add 1 to both sides, and I'm going to get, or rather, whoops. I don't think I want to add 1 to both sides. I think I probably want to subtract 1 from both sides, because that will get rid of that, right? So I'm going to have y minus 1 equals -x squared minus 5x. And now it would be my preference to get rid of, I can't have a negative, I can't complete a negative square because I can't make a negative square. So times by negative 1, and I'll end up with negative y plus 1 equals x squared plus 5x. And now it is time to complete our square. So I have x squared, but now I have to do 5 over 2x. 5 over 2x, because at this point I need to make a square, so I have to take half of the 5 there. If you notice in the previous examples, we always took half of the 6, and we put them here and here. So now it's a little different. I've got 5 halves and 5 halves. So my what it takes to complete the square is a little bit different, right? I've got x plus 5 over 2 by x plus 5 over 2. And now what I have to do is multiply. Here's where you're going to use your fraction buttons in your calculator. 5 over 2 times 5 over 2, which is just 5 times 5 divided by 2 times 2. So that would be 25 over 4. Okay, 25 over 4. And I'm going to have to add that into both sides. Negative y plus, now I'm going to do something here and write 4 over 4. I'm trading in that 1 for 4 over 4 because they're equivalent. Plus 25 over 4. It just makes it easier to add my fractions. Then it's x squared plus 5x plus 25 over 4. So you can see that that's all right there, represents a single, the right side of the equation. And now I can do some simplifying. So again, the big question here is, why did I write plus 1 as 4 over 4? Because I had 25th fourths over here in my perfect square. So if I add those together, I'll get 25 over 9. I'm simplifying. Negative y plus 25 over 9 equals x plus 5 over 2 squared. And now I'm going to have to subtract 25 over 9 on both sides. Negative y would equal x plus 5 over 2 squared minus 25 over 9. I don't really want to have an equation that says negative y equals. It would be preferable to have y equals, so I can multiply both sides by negative 1 again. And I'll have y equals the negative of x plus 5 over 2 squared plus 25 over 9. So in this case, I have a vertex of negative 5 halves, or that's 2.5, comma, 25 over 9. And this one will be opening down, so it's shifted up by 25 over 9. And 25 over 9, 9 plus 9 is 18. So that's 2 7/9. So it's up almost 3 units, the vertex. And then the x value is negative 2.5. Okay, so that's how you complete a square when you have a fraction. So what you'll need to do now is the homework that's been assigned, and hopefully you've got enough of a background to work through those questions.